So question 6, for the quadratic function f of x equals -4x squared plus 2x plus 4, answer parts A through C. So again, A says graph the function by determining whether the graph opens up or down, and by finding its vertex, axis of symmetry, y-intercept, x-intercepts, if any, so forth and so on. So again, does the graph of f open up or down? So remember, in your function, f of x equals this -4x squared plus 2x plus 4. The coefficient of the quadratic term, the -4, is going to tell me whether it opens up or down. That's where the reflection happens at. So since that's -4, this is going to be reflection over the x-axis. So it's now going to be opening down since it's negative. To find the vertex of the parabola, again, if our function is f of x equals this ax squared plus this bx plus c, we can use the formula x equals the opposite of b over 2a to find the x-coordinate of the vertex. So notice how our a is a -4 and our b is actually a 2. So if I take the opposite of a 2, that's going to be a -2. And then I have 2 times -4 on the bottom. So that's going to be a -2 over a -8. We know a negative divided by negative is a positive, and 2 does go into 2 one time, and 2 does go into 8 4 times. So that should reduce down to 1/4. So again, if I type in negative, not here, we'll clear that. If I type in -2 divided by -8 into the calculator, it also gives me this 0.25, which is the same thing as 1/4. Or again, if I hit the math button, change it to a fraction, 1/4. So that's going to be the x-coordinate of the vertex. So then to find the y-coordinate of the vertex, we have to substitute the 1/4 into the function. So y is going to equal, because remember, f of x stands for y. So I have this -4 times this 1/4 squared plus 2 times this 1/4 plus this 4. Now remember, 1/4 is the same thing as 0.25. So I'm actually going to just use this 0.25 to make it a little bit easier to type into the calculator. So -4 in parentheses, 0.25, close parentheses, squared, plus 2 times 0.25. And then we're going to add a 4. Hit enter, and that gives me 4.25. So y equals 4.25. So notice how it says they want fractions, though. So if I hit the math button, change it back to a fraction, that's going to give me 17/4. So the vertex as an ordered pair will be 1/4, 17/4. So for us, 0.25 and 4.25. Now, again, I can also type in y equals into the calculator and type in -4 x squared plus 2x plus 4. If I graph that, notice how it does open down. And the vertex does look kind of not quite to 1. So if I hit the trace button, I don't need a second button, just trace. Notice that that's telling me around 0.30, 4.23, which was really close to what we had. Now, if I want to find that exact point, notice that that's not actually a maximum, that's a high point. So if I hit second calculate, if I use number 4, that'll locate the vertex because it's a maximum in this case. So my left bound, I have to be left of the vertex, hit enter. Go to the right side of the vertex, hit enter a third time, it'll take me to that. Notice how it has this 0.25 and then some, but that's basically 0.25, 4.25. So in other words, 1/4, 17/4 would be the answer to that. So let's check out. So the axis of symmetry is the same thing as the x-coordinate of the vertex. So x is going to equal this negative b over 2a. And since we've already done this math, it's going to be 1/4. So the axis of symmetry is going to be an equation, x equals 1/4, because remember, it represents a vertical line. A vertical line is defined by the equation x equals, and whatever the value is of x. So that's like the vertical line test. So notice there's going to be this vertical line passing through 0.25. That's going to help us. If I was graphing this freehand, it would help me kind of balance out the symmetry of the graph. To find the x-intercepts, we have to set y equal to 0 and solve for x. So that's going to be this negative 4x squared plus this 2x plus 4. We want to set that equal to 0. Now, since all these terms are even, what I could do is divide everything by -2 to make this problem a little bit easier. Because remember, since now it's an equation, you have the property of equality. So that first term is going to turn into a 2x squared. Then we have minus x. We have -2 is equal to 0. So the question is that going to be factorable? Well, one way to factor this, since there's a coefficient in front of the quadratic term, is use 4 squared. So the quadratic term goes here, 2x squared. The constant goes down here, the -2. But the catch is when you make the big T, you actually got to multiply the 2 times the -2 there. So 2 times -2 is going to be -4. So the questions are, what are the factors of a -4 that have to give me a -1? So I do have a 4 and a 1 and a 2 and a 2. Well, I'm not seeing that happen. So this doesn't look like this is going to be factorable. So if it's not factorable, then we can use what's called the quadratic formula. But also it does say round decimals to 2 decimal points. So we can use other strategies here. But it does kind of mention that we can round to 2 decimal places. So remember, x-intercepts are also called zeros. So on my calculator, if I hit the second button, hit calculate, if I use number 2 for zeros, to find that the x-intercept over here, I have to be left of it, hit enter, get to the right of it, that looks to the right of it, hit enter again, instead I get this point, -0.78. So -0.78 would be the one of the x-intercepts. And then the other y-x-intercept, if I do that calculate again, number 2 for zeros, kind of get over here to the close to it, hit enter, gotta be on the left side of it. Then you gotta be cross over to the right side of it, hit enter again, and we get 1.28 if I round to 2 decimal places. We also could use the apps button on our calculator. Apps button, number 7, it gives me what's called root finder, and this number 1. So it is a second degree function. We want real answers, so that all looks good. So on mine, I have to hit next here. Then I just fill in these pieces here. Yours may be different, but it's kind of got the same idea. So we could go back to the original problem if we want. -4, hit enter. This was a +2, so a plus sign, put a 2. That was a plus sign, and put a 4 in, hit enter. And if we hit the solve is the graph button, it'll say it does give me this -0.78 and this 1.28. So it kind of solves it that way as well. Another way to do it would be actually using the quadratic formula, but since I don't really have a whole lot of room here, it's a little trickier to do that. Let's see if I can find a spot here. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So your b is that -1. So the opposite of a -1 is a +1, plus or minus, and then the square root of, and then a -1 squared would be a 1, minus then 4 times a. A was a -4. No, a was a +2 now, and c was a -2. This is going to be all over 2 times a, which would be 2 times 2 would be 4. So we have like 1 plus or minus the square root of, and this is going to be 1, and that's 4 times 2 is 8. 8 times -2 is -16. So that's going to be 1 plus 16, which is actually going to be 17 over 4. So I would have 1/4 plus or minus the square root of 17 over 4. That would be the exact answer. But again, I could type this into the calculator. Again, I could, let me see if I can quit this here. Number 6. All right. So if I type in, I only use the fraction button, alpha f1. So we'll have 1 plus the square root of 17 divided by 4. Notice that gives me that 1.281. And then we have, if I do that fraction again, alpha f1, number 1 minus the square root of 17, and go down and put a 4 in. Also gives me the -0.78. So that would be our two x-intercepts. So they're not very friendly there. So our y-intercept would be setting x equal to 0 and solving for y. So if we set x equal to 0, so if I set x equal to 0, we're going to have y equals, again, I'm going to just, doesn't matter which function, let's just use the original one here. I have -4 times 0 squared plus 2 times 0 plus 4. Notice how it's going to be 4. So the y-intercept would be 4. So if I look at the table, notice that the y-intercept is 0, 4. So if I was want to use this graphing tool, I'm going to hit the parabola. I have to first plot the vertex. Notice the vertex is a little tricky because it's decimal, so you got to look for probably 0.25 and 4.25 for that. So you're going to be looking for 0.25, 4.25. That's going to be your vertex. And then the other thing you're going to do is graph the y-intercept, which is 0, 4, since that's the easiest other point to plot. So I think that should take care of that question there. So now the domain. Remember the domain, since this is a quadratic, the domain is the set of real numbers, so there's no issues there, -infinity to infinity. But remember the range, since there is a maximum value here in our graph, if I go back over here, you'll kind of see my graph. So if I want to translate that over here, it's hard to do, but it's kind of going to be looking like that. Opening down. So notice that there's that critical point, 0.25, 4.25. So notice that the highest point the graph hits is 4.25, and then it goes down. So again, remember when you do range, you have to do lower bound to upper bound. So -infinity to 4.25. So -infinity to 4.25, and we would include the 4.25 in our range. It is a value that we have there. So increasing and decreasing, notice that the graph does start out increasing. So from -infinity, and again, remember we're using the domain values, the x values here, the interval. So for -infinity to this 0.25, it's going up. So from -infinity to 0.25, it's increasing. And we can close that in, I believe is what they've been doing. I don't think it really matters there on the endpoint. I think they've been using the closed. And then notice that decreasing, again, you go from left to right. So at 0.25 to infinity, the graph is decreasing. So they usually include the endpoint. So 0.25 to infinity, the graph is going down or decreasing. So again, when you talk about the interval, we're talking from left to right. So we have to pay attention that we're using the x values. But notice how we're watching the how the graph travels. So while we're looking left to right, what are the y values actually doing? If they're going up, then it's increasing. If the y values are going down, it's decreasing. I can also probably see this in a table, but the catch in the table is we don't have this 0.25 identified. So that's where it's a little trickier.